Hello everyone, my name is Qian Shi from Yat-sen University. It's my honor to be here to share our work with you. Today my topic is evaluation of sea ice thickness from 4 reanalyses in the Antarctic Weddell Sea. Here I also want to thank the co-author François Massenet from the University of Leuven and Matthew Mazaloff from Scripps Institute of Oceanography. In the past 4 decades, the Arctic sea ice extent underwent rapid decrease, but the Antarctic sea ice increased before 2016 and decreased after that. This big change will influence the sea ice in the Antarctic. Previous studies indicate that most of the sea ice in the Antarctic belongs to the level ice. However, Williams' work points out that there are abundant deformed ice in the Antarctic. That means we still have very limited knowledge on the sea ice thickness in the Antarctic. The point observation is mainly refers to the upward-looking sonars in the Weddell Sea. It has a high continuity but relatively low spatial coverage. The line observation refers to the visual observation in the ship during the melt season. It has a low cost but relative low continuity at the same time. It usually ignores the thick ice. The surface observation usually from the satellite altimeter like ISAT, Isat2, Envisat, and situ. They observe the freeboard above the sea levels and have high spatial coverage but relative low time span. Another way to investigate the Antarctic sea thickness is modeling and data assimilation. A typical assimilation system includes the ocean and the sea ice coupling model, which is driven by atmospheric forcing. It will include the ocean states or sea ice concentration. Previous studies indicate that the model and the data assimilation system can reproduce the variation of the sea ice concentration, but they cannot well reproduce the variation of sea ice thickness, especially the thick ice in the Weddell Sea. So our work will focus on the question, can reanalysis ice thickness reproduce the spatial distribution and variation of Antarctic ice thickness? And we will using mooring observation, navigation observation, and remote sensing data to evaluate the seasonal observation and the spatial distribution of the sea ice thickness from reanalysis. Here is the detailed information on 4 sea ice thickness from the reanalysis we used. The GECCO2 and SOSE are both based on the MIT GCM, and the SOSE also assimilate the sea ice concentration using the optimal interpolation. The NEMO-EnKF are based on the NEMO, coupled with the LEM2. It also assimilates sea ice concentration using an ensemble Kalman filter. The GIOMAS is the global version of the famous biomass in the Arctic. It assimilates sea ice concentration by simple nudging. First, the ice thickness from reanalysis are compared with that from US observations. All 13 US observations can be classified into 4 types based on their mean values and their standard deviations. From west to east is the Antarctic Peninsula, central Weddell Sea, southern coast, and the eastern Weddell Sea. In general, all 4 reanalyses underestimate the ice thickness based on their telegrams, and Antarctic's Peninsula southern coast present more obvious underestimation because they have much more deformed thick ice. In the western Weddell Sea, which have much more first-year ice, the SOSE, GECCO2 and NEMO-EnKF present high correlation and low root mean square errors. But the GIOMAS have the much higher standard deviation there. It means that the GIOMAS overestimate the seasonal variation of ice thickness. Then we compare the ice thickness from Reanalyses with that of aspect. The main difference between them on the histogram is the abnormal peaks of the Reanalyses. Usually this peak refers to the ice thickness of level ice. And our work also confirms that this abnormal ice thickness are mainly located in the eastern Weddell Sea, which are occupied by the first-year ice. And it indicates that the Reanalysis state or overestimate the thickness of the newly formed ice. After the comparison with the CS thickness from altimeters, we found that all four Reanalyses underestimate the CS thickness generally, and the SOSE present the largest underestimation. Based on the Isat and Envisat, the thick ice in the Weddell Sea shift from the southern and western Weddell Sea into the west and northern Weddell Sea from autumn to spring. And only NEMO-EnKF and GIOMAS can reproduce this shift well. However, the GIOMAS present obvious overestimation in the central Weddell Sea. Here we compare the seasonal variation of different Reanalyses using the model ice thickness. It is the circles in the PDF figure. The main difference between the Reanalysis date and altimetry occurs in the autumn. For example, the GECCO2 and SOSE present relatively low model ice in the autumn, which means these two dates cannot keep much of the multi-year ice in the Weddell Sea. NEMO-EnKF and SOSE can well reproduce the seasonal variation of the sea ice thickness in the Weddell Sea. In the further study, we calculate the ice area flux across the northern and eastern boundaries of the Weddell Sea. It is noticed that the GIOMAS have the relatively low ice flux across two boundaries. It is in favor of keeping most of the thick ice in the Weddell Sea, so it has better ice thickness than SOSE. SOSE presents the strongest northward ice motion in the western Weddell Sea, which present it keeps the thick ice in the Weddell Sea and make it underestimate the sea ice thickness most. In summary, our work indicates that all four Reanalyses underestimate sea ice thickness in the western Weddell Sea with highly deformed perennial sea ice. NEMO-EnKF and SOSE can well reproduce a large-scale spatial distribution of ice thickness with seasonal changes. In the future, optimization of assimilation system, attention should be paid to the influence of CS motion on ice thickness. Thanks for listening.
So I think Qian's online and available to take questions if anyone has any questions to ask.
we have plenty of time for questions if you have some. So none of these systems assimilate sea ice thickness directly, right? Is that they don't assimilate sea ice thickness directly?
I think the GECCO2 has the simulated sea ice thickness based on the optimal parameters.
Okay.
I see there are questions from the Frederick. He asked, in the next step, we plan to do some optimal work on the topography of the Antarctic, especially in the Antarctic archipelago. Maybe the coarse topography are not fit for keep the deformed sea ice in the Antarctic archipelago, and it's were in favor of more sea ice, six sea ice outflow from the Weddell Sea into the Southern Ocean.
Guys, we can't actually see any of the questions coming up in the chat. Are they open only to panelists or something? And I need to have special.
Is there another question on the chat?
Yes, but those are just some delayed answers from Aliette.
Other questions from people here?
Well, I could read out Aliette's answers. So I think somebody asked about the densities. So in the NEMO model, she uses fixed densities, sea ice density of 900 on, is that multi-year ice, and 917 on first-year ice. Snow density is 300, water density is 1,024. And then this might have been the second question for the in-situ campaigns. They were also taken in spring for the Air EM campaign. I think that was the question over there.